Hi, this is Sarah Razanfari. In this video, I'm going to talk about question number 2 of homework 5, probability in a stochastic processes course. Okay, in the question number 2, we have a joint distribution of x and y, and we should answer 4 questions with respect to the joint distribution. So the first one is draw the non-zero definition region of f, x, and y. So we know that y is bigger than 1, is larger than 1, and x is between 1 divided by y and y. So we should draw uh, y equals to x, and actually we should draw x equal to y and equals to 1 divided by y. And between these two, one of them is a line, the other one is a curve. It is our non-zero region. So let's go to my answer. As you can see, uh, draw y equal to x and x equal to 1 divided by y. And between this curve and this line is a place that we have the probability is non-zero for the joint distribution. Okay, let's go to part 2 of this question. Find A so that the joint distribution is a valid density function. So we know that a valid density function has this criteria, that if we calculate the integral of the probability density function over x and y, then this area should be equal to 1. So at first I calculate the integral with respect to x and then with respect to y. And we have these ranges from the question. We know that x is between 1 divided by y, and y is greater than 1. So at first, we calculate the integral for x, and we have 1 divided by x, which is ln x, and we should substitute y and 1 divided by y. And after that, we should calculate the integral with respect to y. And for solving this, we do some reparameterization because ln is a little bit hard into integral. I define another parameter which is z, and y equals e to the power of z, and dy is equal to e to the power of z dz. So I will substitute all y's with z's, all y with actually e to the power of z, and here we should calculate the integral for this formula, which is much more easier, and we will get to, and after doing some calculations we can find a equals to 2. Let's go to the other part, which is part 3. In part 3, we want to find and draw the marginal density functions. For doing so, let me go to the next page. Okay, if we want to calculate the probability density function for x, we should calculate the integral of the joint density function with respect to y. And so again, so we should calculate this integral with respect to y, which is easy, and here is the answer. And we put our ranges into this formula, and we get to 1 divided by 2 x to the power of 2. As you know, x This actually range is for x between 1 and infinity. But we know that this is a density function and the integral should be equals to 1. So we have a 1 divided by 2 for the range between 0 and 1, and the area is 1 divided by 2. And then we have the integral that we had calculated, which is 1 divided by 2 e to the power of 2. So this is the probability density function of x. Now let's go to the probability density function of y. We want to find the marginal distribution of y. Again, we know that we should calculate the integral, but now with respect to x. And this is simple. We have 1 divided by x, which the integral is ln x, and we substitute with our range, which is 1 divided by y and y, and we get to this formula. In part 4, we are asked to verify whether these marginalized density functions are valid or not. So a density function is valid if its integral from minus infinity to plus infinity is equal to 1. So we are going to calculate the integral of probability density function of x from 1 to plus infinity, and it's very simple. We will get to 1 divided by 2, and as I explained earlier, we have another part which is from 0 to 1, and we have another 1 divided by 2 here. So the plus of these two is equal to 1, and this is a valid distribution. Let's go to A. Let's go to Y. We need to calculate the integral of marginalized density function of y in the range 1 to minus 2 plus infinity. And again, we will do the reparameterization because ln is hard, and we will substitute it with another parameter that I have written here and explained in another parts, and we will get to, and again we will change our parameters from z to y so that we can apply our range, and after applying our range we will get to 1. So both of these marginalized density functions are valid. Thanks for listening to me, and bye.